Hello and welcome to another episode of IcyGaming Teaches Chemistry, the world's most respected source of chemistry facts, in my opinion. As always, I'm joined by my marvellous assistant, Jonathan the Horse. Today, we'll be learning about the wonderfully smelly world of esters and carboxylic acids. Carboxylic acids are called weak acids, but why? Isn't it disrespectful? Nay. That's right, Jonathan. It's because they only partially dissociate into H+ ions, which are what makes things acidic. As you can see, the reaction is reversible. Weak acids are still able to react in acid-base reactions, such as with carbonates, so it can liberate CO2 from them. If a carboxylic acid reacts with an alcohol, what happens? Well, not much, unless you have a strong acid catalyst. If you do, then
Kaboom!
they react in something called a condensation reaction. This forms an ester. We make esters because they smell nice, and so often use them in perfumes. They also get used in food flavorings and can be polymerized into polyester to make plastic bottles or fibers of clothing. My cape is polyester. Vegetable oils and animal fats are esters of propane 1,2,3-triol, also known as glycerol. An animal fat or vegetable oil looks like this, which is pretty much the same molecule, but with a bit tagged onto the end to replace the hydrogen. Well, quite a long bit. We can form alcohols, carboxylic acids, and salts of carboxylic acids from esters by using a fancy process known as hydrolysis. This is made up from the two words hydro, meaning water, and lysis, which apparently denotes decomposition according to Google. There's a fun fact to tell your friends. The esters can be hydrolyzed by dilute acids or by alkali, but it's usually done with alkali, as shown by the mechanism that Jonathan's drawing for us right now. The lone pair on the OH- is attracted to the partially positive carbon atom. The double bond also transfers an electron to the oxygen atom. In the next step, the lone pair on the oxygen goes back to the single bond, and since the carbon atom now has 5 bonds, the OR detaches from the carbon. The lone pair on the oxygen is then attracted to the hydrogen atom, which detaches from the molecule. In a full reaction, a positive ion such as Na+ would attach to the product. If you hydrolyze large esters, such as those found in animal fat, using concentrated sodium hydroxide as a catalyst, it forms a salt of a carboxylic acid, such as ocodecanoic acid, also known as stearic acid, which is commonly found in soap. I would have drawn the full molecule for it, but sadly my expertly drawn board does not have the space. Another interesting fact about esters is that they make up biofuel as well as long-chain carboxylic acids. Vegetable oils are reacted with alcohols in the presence of a strong alkaline catalyst, such as sodium hydroxide. The glyceride, which is either the animal fat or the vegetable oil, and the alcohol, form the methyl esters that make up biodiesel and glycerol. Well, that's the end of today's chemistry lesson. Don't forget to subscribe for more chemistry top tips with world-class explanations. Goodbye, and I hope you all enjoyed this esterlent video.